We're now going to find an unknown vector when you're given other vectors between points. So if we look at this question here, it gives us the position vector of a point A in column form. It gives us the position vector of a point B in column form. And then it asks us to work out the displacement vector AB. Now you can clearly see that there's 3 points in this question. There's the origin, there's point A, and there's point B. So before we find an unknown vector, we need to draw a diagram. So we're going to draw a very simple diagram with 3 points. There's no science to this, we're not plotting them exactly or making sure they're in a reasonable position. Just randomly put 3 points on your page. So there's 1 point, there's another point, and there's the 3rd point. And again, there's no reason why I put this here and I put that there and I put this point over here. Just draw a diagram with 3 points and label each point with a letter. So I'm going to let this be the origin, O, and then that's going to be point A. Again, no reason why I'm making it point A. And this is point B. No reason why I'm making that point B either. So we're going to join the 3 points together. Like that. Now, we have to put the displacement vector AB that we're trying to find on the diagram. So the displacement vector AB is the vector that runs between A and B and is running away from A to B. So on the line AB, I'm going to put an arrow pointing away from A and towards B. So that's our displacement vector AB. I need to put arrows on the other lines to turn them into vectors. So remember, OA is a position vector, and position vectors are always directed away from the origin. And likewise with OB, position vectors directed away from the origin. What I'm now going to do is take the position vectors that are given in the question and write them beside the position vectors in the diagram. Now I'm going to write them in component form. So OA is 2i plus 3j. Again, I'm going to put brackets around it because they all belong to OA. And then OB is going to be 6i minus j. And again, put brackets around those because they belong to OB. Now that we've got our diagram set up, we're in a great position to work out the displacement vector. So part A, the displacement vector. Now, anytime you're trying to work out an unknown vector, always make that vector the sum of all of the other vectors from its tail to its nose. So what I mean by that is, when you're travelling from A to B, that's the displacement vector that we want. That's the same as travelling from A to O and then travelling from O to B. So to get any unknown vector, you make it the sum of the other vectors from its tail to its nose. So we're going to be adding these 2 vectors together. However, when you're moving along a vector and you're moving against its arrow, you need to make the vector negative. So this vector we must make negative because we're starting at A and we're traveling this direction, so we're moving against the arrow. So this vector is negative, and then we're adding on this vector here, 6i minus j. So the displacement vector AB, our unknown vector, is going to be negative 2i plus 3j. And then we're adding on the other vector. Notice the other vector we're adding because we're moving in the same direction as its arrow. So 6i minus j. So all we do now is tidy up the I components and the j components and get it into a single I and j component. So we need to multiply the I component here by a negative first, so that's minus 2i. And then we're adding on 6i, so that's going to bring us to 4i. And then multiply the j component by the negative, so that's minus 3j. and then we're adding on a negative j. So we're going to be left with minus 3j minus another j. That's going to be minus 4j. And that is our unknown vector. That is our displacement vector AB. And again, put brackets around it once you work it out, just to keep the I and j components together. Okay, part B then wants us to work out the distance AB. Well, that's actually really straightforward because we've done this before. To get the distance from A to B, we're just looking for the length of the displacement vector AB. So how do you get the length of a vector, or the magnitude? Well, the length of any vector, or its magnitude, is the square root of the I component squared plus the j component squared. So that's going to give us the square root of 16 plus 16, which is 32. If we were to give it exactly, then we would simplify the surd. Largest square number that goes into 32 is 16. 16 times 2. And then that would be, if we break up the surd, root 16 times root 2, that's going to give us 4 root 2. Or, if we weren't giving it exactly, and we were using our calculator, so we'd take the square root of 32, and that is going to give us 5.6568. So our final answer then, the distance AB is 4 root 2, or 5.66 units, and that's to 3SF. Part B. Okay, let's look at part C. So part C wants us to find the position vector of a point C such that AC to CB is in the ratio 3 to 1. Now, AC to CB is implying that we're taking the line AB and we're breaking it up into two parts. We're breaking it up such that one part will be worth 3 and one part will be worth 1. So, where do we put C on the line AB? Well, the length AC is 3 parts and the length CB is 1 part. So AC is 3 times the size of CB. So C must be closer to B than A. So I'm going to put C somewhere there. Okay, so A to C is 3 parts. So I'm going to put that on the diagram. And C to B is worth 1 part. Now we don't know the actual lengths, what their lengths actually are. We don't know what 1 part actually is, but whatever it is, we know that AC is 3 times the size of CB. And A to B is worth 4 parts in total. So it's important to get that information on your diagram before we proceed. So part C is asking us to work out the position vector from O to C. So I'm going to put that in the diagram. So the position vector joins O to C. And remember, it's always directed away from the origin. So we put an arrow pointing away from O and towards C. Now again, we are trying to find an unknown vector, O to C. So remember, to find an unknown vector, you make it the sum of all of the other vectors from its tail to its nose. So travelling from O to C is the same as travelling from O to A. So you travel along this vector and then travel from A to C. Do you notice that in our travels here, we're not moving against any arrows, we're moving with the arrows, so we don't need to make any vectors negative. So O to C means we're going from O to A, so it's vector 2i plus 3j, and then we're adding on vector AC. Now, vector AC is 3 parts out of 4 parts. Hopefully you'll agree. AC is 3/4 the length of AB. So vector AC is 3/4 AB. So it's going to be 3/4 the vector AB. Now what is vector AB? Well, if you go back to part A, we worked out vector AB. It was 4i minus 4j. So it's 3/4, and then we're going to have 4i minus 4j. So that is quite tricky. Okay. So then what we're going to do is multiply this vector here by 3/4 and then add the two vectors together at the end. So we've got 2i plus 3j. Copy down our plus, keep the sign between the brackets, and then multiply the bracket by 3/4. So we're going to end up here with 3i minus 3j. Then we just add the 2i components. So 2i plus 3i is going to give us 5i. And then we're going to have 3j plus minus 3j becomes 3j minus 3j, which is 0j. We could leave it like that, or just ignore the j component because it doesn't have one. So our final answer would just be 5i. So that's what the position vector OC would actually be. It's actually not a bad sketch because 5i would imply it's a horizontal vector. There's no j component to it, so it's not a bad sketch, but it doesn't matter if it doesn't fit with your sketch. The sketch is only designed to help you work out what unknown vectors are.